Technology is racing ahead at an incredible pace. Not only are new products with improved performance and new features introduced every day, but product life cycles are gradually getting shorter. In electronics, it all starts with fast prototyping of printed circuit boards, the backbone of any electronic product. Companies usually outsource production to a third party, often overseas vendor. Prototypes take weeks before they are sent back for testing. Not to mention security risks related to exposing confidential designs to third parties. Oh, and any design revisions may require another cycle, turning weeks of waiting into months. But what if you could take all the outsourcing hassle out of the equation and squeeze all the prototype production processes into one box in your own office? Well, now you can. Introducing the Dragonfly 2020 3D printer by Nano Dimension. Combining 3D inkjet technology, highly specialized nanoparticle inks, and advanced software, the Dragonfly produces advanced PCBs quickly and easily. Now you can innovate and experiment freely and easily test every detail of your design without losing time. But perhaps most importantly, the Dragonfly 2020 offers nearly limitless design flexibility. So take your business into the future of PCB prototyping. Advance to the Dragonfly 2020 3D printer by Nano Dimension.
We like having things right away. When you need a cup of coffee, you just push the lever down. Calling a cab is now as easy as tapping for one. And when programming, you can see if your code works at the click of a button. With the Volterra V1, if you need custom circuit boards, just press print.
We've all been there. We send a circuit design off to a factory, wait 2 weeks for delivery, only to find that there's a mistake. A design takes a couple of iterations to perfect, but who's got the time for version 2, 3, or 4? Just create your layout in whatever program you're already comfortable with. Pass our software the Gerber files, and then press print. We designed this tool to help hardware developers see their ideas come to life faster than ever before. We use conductive and insulating ink to create fully functional 2-layer circuit boards without ever having to email files around or wait for the FedEx truck.
But this is so much more than just a prototyping tool. It can help you in any stage of development. For small batch runs, the printer is also a standalone solder paste dispenser. Once you add the components, it will reflow the board as well.
Go ahead, toss out all those stencils. You won't need them anymore. We've used our backgrounds in nanotechnology and mechatronics engineering to really push the boundaries of this technology. The past 2 years have been spent in chemical experimentation, making sure we hit our benchmarks for conductivity, solderability, and reliability. Last year, we made the decision to move to Shenzhen, China, the electronics capital of the world. This allowed us to nail down our supply chain and manufacturing processes. Living there was one of the many amazing experiences we've had, bringing this dream to life.
We've spent enough time in cluttered workshops, dirty garages, and electronics labs. So we knew that our product needed a small footprint, a durable aluminum body, and a beautiful design.
3D printers and development boards have made prototyping a bit easier. The barriers to hardware are falling all around us, and it's about time the barriers around access to circuit boards fell too. We're only able to launch our product because of Kickstarter and amazing backers like you. We are all part of the now generation, and if we're building the technologies of the future, we need tools that can keep up. This is just the first step for us. There's so much more we want to build, and so much more we want to contribute to the hardware community. We hope you take the time to back and share our campaign. We can't wait to see what you create.
Hi, I'm Danielle Applestone. And I'm Mike Guesty.
And we work at a place called Other Lab, which is an R&D firm out of San Francisco. And for the past year, we've worked on low-cost digital fabrication machines.
And we've designed a miniature mill that's light enough to carry with you on public transport, but still strong enough to cut metal.
The other mill is a desktop CNC machine. It was originally designed just for PCBs. The bed size is roughly 5 inches by 4 inches, and there's 2 inches of Z travel. Flexures are built into the linear rails for adjustment to get perfect alignment. The machine is really simple, quiet, efficient, and easy to use.
It's as simple as taking a board, set it on the bed, load up a board file, position it, and hit go. And then it will cut your board out. It's really easy to build carrier boards for sensors or switches, front panel displays, button carriers. This makes prototyping custom circuits and designs a lot easier. 3D printing is an additive manufacturing process where you stack up layers of material to get a particular shape. And it's a very limited number of materials that you can use. A mill is a subtractive process. You cut away the material.
In addition to being able to cut PCB boards really well, it's also useful for cutting metal and wood and plastic, so you can do all kinds of things like engraving or making your own molds, casting, things like that. So it has a lot of applications even outside of electronics. We have expertise in software, mechanical engineering, and community development.
We have the tools in-house needed to make these machines for the first batch here in San Francisco.
To bring these machines to you at a price that we think is affordable, we need your support.
To help buy materials and get volume discounts and to build out our factory. Thanks for watching.
"3D printing is ready for change." What would you do if you could 3D print electronics?
At Voxel 8, we're revolutionizing 3D printing by developing a full three-dimensional electronics printing platform.
So if you take a look at a lot of what's been printed up until now, it really amounts to trinkets in 3D printers. And as we look to the future, that's where I think we're going to start creating things that only 3D printers could have made.
The circuits of today are flat two-dimensional circuit boards that are embedded into three-dimensional cases. This whole paradigm is going to change because we're enabling designers to create circuitry and physical objects at the same time using Voxel 8's 3D printing technology.
Over the past decade, the Lewis Group has carried out thousands of experiments to create new materials for three-dimensional printing. I'm really excited to move this technology out of my lab into Voxel 8.
With our Developers Kit printer, you will be able to integrate electronics into mechanical objects. You will be able to print devices like quadcopters and integrated electromechanical assemblies that typically have to be manufactured through multiple methods. Our conductive ink is specifically formulated for 3D printing, prints and dries at room temperature, has excellent electrical properties, and has excellent adhesion to other matrix materials.
We want to make it simple for users to create 3D printed parts with embedded functionality. We've partnered with Autodesk to make an end-to-end pipeline to do just that.
Wire enables users to bring in their CAD models, to place components, to route wires in 3D using the Autodesk Spark platform. And that's really happening for the very first time. The software for this simply did not exist before.
We're fundamentally materials experts, so we created a platform specifically designed to be upgraded with different materials as we release them in the future. Our printer prints similar to typical 3D printers, layer by layer. To place a part, the printer stops, allows you to remove the bed, place the part inside of the material, and then replace the bed on the printer. It will print right where it left off, knowing that there's a part inserted inside of it.
We're excited to work with companies like Voxel 8 because they're really pushing the boundaries of where 3D printing is capable. And by incorporating conductive inks directly in the 3D printing process, we can start to create things that have function after they're created.
In order for 3D printing to reach its full potential, we need a broad palette of functional materials, coupled with the ability to have a multi-material 3D printing platform. With these kinds of tools at hand, we can truly print our imagination.
Prometheus is a desktop machine that makes real circuit boards in just minutes.